All right, before jumping into this, I'm going to give a brief overview of how this whole thing is going to work. Basically, we're going to start off with our laptop. We're going to conduct some network scanning using the inSSIDer and airmon-ng tools. After that, we're going to discover our target network, which I've named moldarknet. From there, we're going to enumerate some wireless clients on it using Kismet, at which point we will discover one or two. We will send deauthentication frames using the aircrack-ng tool. Once that client has been disassociated from the network, it will attempt to rejoin either automatically or manually by the end user. After that point, we are going to not intercept, but we're going to read that traffic using the airodump-ng tool and then get that WPA handshake between the client and the access point. After that, we're going to crack the password using aircrack-ng, and then once we've cracked that password, we can join the network ourselves. So, yeah, and then after that, I decided, hey, why not? We're going to attack the router using Hydra, and then compromise the web interface for the router, and then after that, we're basically done. We own the network. So, oh, and the last thing we're going to do is, I noticed from once we gain telnet access to the router as well, or, well, telnet, or if you want to go after the router's backup file, if you get access to either one of those things, we can use John the Ripper to crack that password. So I'm going to cover that as well at the end. All right, so the first thing we see here as I'm scanning is the network I've set up, which is moldarknet using the inSSIDer tool. So we can click on this, get some more information about it. Only pertinent things about this really are its MAC address, right, or its basic service side identifier, and then the channel it's running on, which is 11. All right, so we can get the same results using some Linux-based tools as we did from the inSSIDer or the inSSIDer program. So we can go ahead and do that really quick with, if I can spell, this is my USB wireless device I'm using. This, okay, so we can, let's see. Yep, that is, okay, we gotta set that interface down before we do anything with it, so sudo IP link, copy that, whatever, for you it might be called, VLAN 0, or WLAN 0, whatever it's called. Go ahead and set that interface down. After that, we're going to set that interface into, monitor control mode. All right. And then bring that interface back up. All right, at this point, we're going to start that airmon-ng tool I talked about in the very beginning of this, and we're going to do that using that wireless interface I was talking about. And then this is sort of cheating, but not cheating. From the inSSIDer thing, we know our network is running on channel 11, so save ourselves some time in the future, go ahead and include the channel number right after it. Okay, let's go ahead and kill all of these processes. What we got? All right. Try that one more time. There we go. Okay. So now that's been started, we can go ahead and run the airodump command, airodump-ng, and that will just be for the wireless interface. And from this, we should start seeing immediately some of the networks around us that we can see with that wireless USB. Mine is only, I forget, what is it, N or something? Well, it might say N, but it only works over the 2.4 gigahertz frequency. But what we can see here is our target network, right? The same thing I was talking about before. We get that, go ahead and pause this actually. We get that MAC address, or that basic service identifier of the access point, as well as the channel ID, which we already knew it to be 11, but this confirms it again, channel 11. All right, we'll be using the MAC address you see here to try and identify any clients that are a part of the target network, which is this moldarknet. All right. So to do that, we're going to use a tool called Kismet, and it's just going to be Kismet-C, and then whatever wireless interface you're using. So go ahead and run that. And then, if this is your first time setting it up, you'll have to go through some extra steps, but that should start a web interface for you at your local address at port 2501 by default. So once you start that command here, that will turn this on. So what we can do from here is sort by the basic service identifier that we obtained before, right, which was that 002485, right, don't forget that. So 002485, go and find that. We have right here. So we can see the actual access point, which is, okay, it's still loading lost, so it's kind of moving around. But we can see this guy and this guy. All right, so the first one is our actual access point. Nothing changed about this. But here we've got a different MAC address, which is the 6894. And that is our wireless clients that we're going to be targeting for our deauthentication frames. So let's go ahead and copy that, because I'll be forgetting that later on down the road. Go ahead and copy that as well. Okay, so client was that, access point was this. Alright, so now that we have the MAC addresses of both the access point and the client that we're going to target, we're going to perform that deauthentication attack against the client. Before we do so, however, the first thing we need to do is set up the interface so that it will be looking for that handshake between the client and the access point. Once it's been disassociated, it'll try to reassociate either automatically or manually. In either case, and I mean manually by the end user, right? If they notice their Wi-Fi is out, they'll try to reconnect. So let's go ahead and clear this out, and we'll be using the airodump tool this time. We know the channel it's on is 11. The BSSID, that is going to be for the access point. So go ahead and copy that, paste. We're listening for that. We'll be capturing this to, let's call this out. I'll be capturing that into a few different formats. I think the one we care about is just a capture file, pcap. It's either cap or pcap, I don't know which one. Anyway, we'll call it out, and then the interface that we're using, which again is going to be, I already forgot what it's called. I've config this thing. Alright, so we're going to run that, and what we're going to wait for really is, once we perform that deauthentication check, we're going to look here for a little thing that pops up that says WPA handshake. And that'll tell us that we have, in fact, gotten that thing that we're looking for. Okay, go ahead and... Alright, so that deauthentication attack now was going to be done using aireplay. So we know we'll perform this 5 times back to back. The access point SSID we know to be this one right here. The client SSID we know is this one right here. And then again, we got that interface, which I need to write this down or copy paste it somewhere. Actually, I'll do that. Okay. Alright, so on that interface, and that should be all of the command, I think. Yes. So we're going to run that a few times, and then we're going to watch here, and hopefully we see something about a WPA handshake pop up at some point. So let's give it a second. All right, so there we go. We now see we got that handshake right here. And the reason that took so long actually is because before I had the client I'm using, that Dell Latitude, which is connected to the network. Initially it was set to connect automatically, but I unset it, and so it was kind of waiting for me to connect manually. So that's kind of a good thing to notice, actually. But anyway, we captured that WPA handshake, and then if we now go to the same directory that we're in right now, we see all these different capture files in different formats, some CSVs, and the out1.cap. So just to kind of show you what this looks like, right? If we open up Wireshark, go ahead and open up that capture file, which is here, out1, open this up. So initially there is a lot of traffic, right? I mean, we're looking at tens of thousands of packets. And so to filter that, we can, I took some research, but, well, very quick research. We're looking for those 802.x authentication packets, right? Because that's what the client is trying to do with the access point. And so we can see here, to filter through that traffic, we got to search using this filter, which is the EAP-OL. I'm not sure what the OL stands for. I'm guessing the EAP is the Extensible Authentication Protocol. I can only imagine. But anyway, so we filter by this. We can see here it captured. Ooh, looks like it actually missed one of the packets. It's got 1 out of 4, but it's missing 3. That's interesting. Well, anyway, so based off the source and destination, we can see the one we're gonna really be looking at here is that second one. And we go down here to some of the info. What you'll see later on actually is this, the message integrity check right here. We'll see that play a role later on. But anyway, doesn't matter. All right, so now that we have that packet capture file, which is this one right here, we can run the aircrack-ng tool against it using this, and then what's called out-01.cap. And then for this, you got to specify which word list you want, right? So the one I went with was, what was it? It was the passwords, and then this 10 million password one. So this is going to be running that tool, trying to crack the password or the hash that was sent in the capture, or in the capture file right here, using the word list located right there. Go ahead and run that, and this will take some time. Realistically, not that much time. Since I set up the network, I know the password obviously, so I didn't choose one that's going to take, a million years to crack. It's just a dictionary attack that's going to crack it relatively quickly. So go ahead and let that run until it finds the password. All right, and just like that, we have our password. So again, this was a very simple crack because, well, it was dictionary based, first of all, and I knew the password going into this. And so I chose one that I could crack in 5 minutes as opposed to a million years, just because I'm, lazy, I guess, that way. So one interesting thing here is we can see in the EAP-OL HMAC, you can see that same hexadecimal output here. If we go to YouTube, cap, open, second frame, you see that same hash, or not hash, but the same hexadecimal right here. So the A89224. So that was interesting. Anyway, so now we have this network. You can go ahead and connect to it. The only issue is you can't connect to it directly right now because your wireless interface has been set to that monitor control mode, right? And so we're going to have to undo all those changes, restart the network manager process, and then we should be good to go after that. All right, so just to get that name. This guy right here. Before we can change its mode and all that, got to set that interface down. So let's go and do that with sudo ip-link set interface down. After this, we can set it back using this and back to its regular manage mode. Go and bring that interface back up now. Alright, looks good. And then we're going to have to restart one of those services we had going before, which was, I think it was this one, Network Manager start. Give that a go. Let's go ahead and try and connect using the password we saw from before, which was that Fire Emblem password. Let's go ahead and try that. Smoldark, connect. Okay, you can type it out, fine. Fire Emblem. Alright, looks like we have connected to it. Let's go and see if that works. We can see that we were assigned an IP address and all the information. Only knowing thing about ifconfig doesn't outright show you the default gateway for this address, but you can figure it out, right? You have the network mask here, the broadcast address, your IP address, so you can figure it out. So just to confirm, let's try and ping that address. We're getting a response, so let's run an Nmap scan. Actually, no, we'll keep it simple. What else we want on here? Shouldn't need too much, but let's just see what this turns out. Alright, so from a scan of the default gateway right here, we can see we've got 3 open ports, one for telnet, one for DNS services, and then one for the web interface right here. So let's go ahead and pull up that interface for the router. So from the landing page, you can actually see more information than you would probably want given out, especially about the connected clients right here. But any attempt to go to any other page like administration or wireless settings, services, any of that, it prompts you with a login screen, right? And so if we cancel that, we can see here we'll be using this part of the URL for our Hydra brute force attack. Well, more of a dictionary brute force attack, but we can go ahead and get that set up. So initially I had a username word list I was using called, I think, top username shortlist.txt, but I did some math and realized that would take around 90 hours to break that. So I'm cheating. I already know the username or the username, but the password is what we're still going to go after. So let's see. Password, the one I chose was from user share, just the default rocky.txt word list. Is that the right place? User share word lists. Yeah, it should be. Let's serve over port 80 over on, let's see, 192.168.1.1. HTTP get, and then, what was it called? It was called status. Oh no, this was a different one. Management ASP. Let's try that. Management.asp. Alright, so you see here that was a very quick attack, or brute force, because, again, did the math. If I did not specify the username, it would have taken it would have worked, but it would have taken 80, 90 hours to crack. So yep, just like that, we've got our username and password. So we can go ahead and use this and try to log into the web interface now. Try it again. All right, and just like that, we've got access to the router. We can modify it as we want, and yeah, I mean, really do whatever you want with it. So one other thing I wanted to talk on really quick is if you somehow got access to the backup file, right? So maybe you found it on a spare file server or something like that, right? I'm not sure we used to open a bin file. Just try Kate. Okay. So this is obviously not the most perfect. Okay, here we go. I think this, yeah, this looks like it. So right here, actually. And I'll show you the same thing over telnet access, over the telnet interface as well. But I thought it'd be fun to get some practice on cracking passwords using John. And so if you got access to the backup file this way, or somehow you had telnet access, go ahead and telnet to 192.168.1.1. And then this kind of threw me off. The username is not admin like it was for the web interface. It is always going to be root for this specific router. I don't know why. We use the same login password. That was incorrect. Why was that incorrect? Let's try that again. Telnet 192.168. Okay, yeah, should be the root password. Maybe the root is lowercase. The root is actually, I'd be willing to bet that's the case. Let's try that. Root, and then there we go. All right. All right, so you got the same password works, but the username is root and not admin. So one interesting thing that I did see was if we go to the etc folder. So the first thing you notice, right, there is no shadow file, right? There is only the older password file. And so if we go ahead and, that's not, I spell that. So here we have the password, which is both the same for root and reboot. There's only that one. So if you got access to this somehow and you were trying to elevate your privileges, maybe you only had access to like a lower level account and you want to get access to the root account, then you could get this password right here. Or like I was saying before, if you had access to the backup file, you see that this thing is the same one as over right here. So we're gonna go ahead and crack that. Only other interesting thing that I saw was if we do a quick LSLA and grep for, I can't type right now. I thought this was interesting just to point out. Doesn't really matter at all. But the password file is actually represented as a symbolic link to the temp folder. So /temp/ etc password. And so it's what you would expect, but what kind of threw me off is that it's the temp folder. And so how is it, really saving the password there, like whenever it shuts down and all that? And the only thing I came up with was that it's somehow, or not somehow, it's just using it's using the configuration file that we're seeing here to mount that into the temp folder, and then that's where it creates the symbolic link between the etc password and the temp etc password. So that was interesting to point out really quick. All right, so we've got that password. Oh no, did I save it? I guess I didn't save it. Let's open this up. Where was it at? password HTTP. Remember, started with this and errors. This guy. Alright, so there's our hashed password. We can go and take that. We'll save that to hashed, like so. And then also, I forget if I used hash ID or hash identifier. Let's see if this pulls up. Okay, I think it was hash ID. So when this thing pulls up, it thinks it's most likely MD5 crypt. So knowing that, we can go ahead and use John, this formats, grep for MD5, John, that's... Alright, and then we do see MD5 crypt, see if there's anything more specific. Long. Alright, let's just go with MD5 crypt then. We can go ahead and use that, and then let's see, that would be John format equals MD5 crypt. Word list. We know the rock.txt file worked, right? So let's use the same one again, just for the practice. So word lists, and then user share word lists rock.txt. And the file we're trying to crack is, I call that what? Hashed.txt. And sure enough, there we go. We see that same password that we saw from the Hydra brute force against the web interface. So yeah, I thought that would be good just to go over one time. You know, get some practice using John, hash ID, all that fun stuff. So, all right.